X is a continuous random variable such that f of x is x over 2, x being between 0 and 1, and f of x is 2 over 3 minus x over 6, x being between 1 and 4, and 0 otherwise. The first part is that you have to sketch f of x. In order to do that, we're just going to go to our GDC, and for that we will select calculation mode, which is that one. No, sorry, graphing mode, which is this one. So selecting graphing mode. Now we need a piecewise function. So to get a piecewise function, you need to go to this one over here, and then select this one here. And it asks you the number of functions you got. We're only going to have put 2 in this time. So we press OK, and we write in the function. So it's x divided by 2. And the second box is for, so you move it with the arrow keys, is between 0, and the inequality signs are over here to go with that. So you need a control. So it's a little bit cumbersome. X control less than or equal to 1. And then the other function is 2 divided by 3 minus x divided by 6. And then here you're going to put 1 control, inequality sign, x control, inequality sign 4. But strictly speaking, you should be able to draw this without a GDC. Press enter and you'll get a small graph over here somewhere. So what we can do is menu, window zoom, and we'll do the box one and make sure we do box it reasonably okay. We need to go up to at least 4 on the x-axis. So we get a reasonable looking graph. Press escape, perhaps move the label, and we get a reasonable looking graph. So there's a screenshot to show the procedure there. And then you draw a set of axes quite large, label them x and f of x. You need to mark on what 0, 1, 4 and a half, and then draw the bits of the graph on, and perhaps label each part. So this is y is x over 2, this is y is 2/3 minus x over 6. Part B, find e of x. So e of x is the integral of all x, or x times f of x dx. So that's from 0 to 1 of x squared over 2 dx, plus from 1 over 4 to x over 3 minus x squared over 6 dx. Integrating, you're going to get x cubed over 6 between 1, 0 and 1, and then this will become x x squared over 3, the 2 will cancel out with the 2 at the bottom, minus x cubed over 18 from 1 to 4. Putting in the limits, so it's 1 cubed over 6 minus 0 cubed over 6, plus 4 squared over 3 minus 4 cubed over 18, minus another set of brackets, 1 squared over 3 minus 1 cubed over 18. So this is just going to get 1/6 from the first bit. Then I'm going to get 16 over 3 minus 64 over 18, which is 32 over 9, minus 1/3 plus 1/18. And then working that out, I'm going to get 5 over 3. Now I can do this on my GDC as well. So going to my GDC, I'm going to press for a calculation mode, and then I'm going to do menu, and I'm going to go for calculus, and I want to do a numerical integral, and then I just put the numbers in. So it's going to be 0, 1, the integral, which is going to be x squared over 2 divided by 2. I have to tell the calculator which variable to integrate with respect to, plus, again, menu, calculus, numerical integral from 1 to 4, and then I'm going to have to put some brackets in here. So put some brackets in. So I want 2x divided by 3 minus x squared divided by 6 and then put the x at the end, and then enter, and make sure I get the same answer, which is 1 2/3, which is 5/3. Screenshot for that one. Find e of x squared. Well, similar process, but e of x squared, we need to add in an extra x. It's x squared times f of x. For all x, it's from 0 to 1 of x cubed over 2 dx. From 1 to 4 of 2x squared over 3 minus x cubed over 6 dx. So they're going to be x to the 4 over 8 when I integrate between 0 and 1, plus 2x cubed over 9, so minus x to the 4 over 24 between 1 and 4. Putting in the limits, I'm going to get 1 over 8 minus 0 over 8, plus 2 times 4 cubed over 9, minus 4 to the 4 over 24, minus in brackets 2 times 1 cubed over 9, minus 1 to the 4 over 24. This bit's just going to give me 1/8. This is going to give me 128 over 9, and from here I'm going to get 32 over 3. Plus 2 minus 2/9, and when I take that minus sign in the bracket here, I get plus 1/4, so a bit of care is needed. So that gives me 7/2. Again, I can go to my calculator and work that out. So I'm just going to make a new screen here. So menu, calculation mode, and then menu, calculus, numerical integral, and then I want to do from 0 to 1 of x cubed divided by 2 x, and then add. So menu, calculus, numerical integral, and again from 1 to 4 of 2x squared over 3 minus x cubed over 6, and again I have to do x, checking that, make sure I got it correct, and then I get 3.5, again 7/3. This is a screenshot. Part D is to find the variance. Well, I found the main components of that, because the variance of x is e of x squared minus e squared of x, so 7/2 minus 5/3 squared, which gives me 13/18. Find the commutative distribution function f of x. Okay, so we have to split this into parts. So the first part is between 0 and 1. So f of x will be from 0 to some x. Now some people like to put an extra variable in here, t, but I'm just going to do from 0 to x of x over 2 dx. So I integrate that, so I get x squared over 4 for x to 0, putting in x over 4, x squared over 4 minus 0 over 4, just gives me, for the first part between 0 and 1, behaves like x to the 4 over 4. Now I need to work out f of 1, because that's at the end of that region. So f of 1 will be equal to 1 to the 4 over 4, which gives me 1/4. Now the reason for doing that is between 1 and 4, I've already got up to 1/4, and then I need to add the integral from 1 to x of the next bit of the function, which is 2/3 minus x over 6 dx. So it's 1/4 of 2x over 3 minus x squared over 12 from 1 to x. Putting in the limits, you get 1/4 plus 2x over 3 minus x squared over 12. So put the limits in red. Minus in brackets 2 times 1/3 minus 1 squared over 12. So it's 1/4 plus 2x over 3 minus x squared over 12 minus 2/3 plus a 12, and that altogether will become 2x over 3 minus x squared over 12 minus 1/3. Right, if I now work out f of 4 for this, putting 4 in at the end, I would expect the answer to be 1. So it's going to be 2 times 4 over 3 minus 4 squared over 12 minus 1/3, which is 8/3 minus 4 over 3 minus a third, which gives me 1 as expected. The final step is to write out, so f of x will be from 0 from x is less than 0, x to the 4th over 4 between 0 and 1, 2x over 3 minus x squared over 12 minus 1/3 between 1 and 4, and 1 for x greater than or equal to 4. Right, the next part is I have to sketch that. I'm going to sketch that now. So going back to my calculator, and I'm going to do another one, and this time I want a graph. Okay, and I need to go, no, sorry, not one, escape. I need to go to this one, sorry, and select this one, and I'm going to put 4 things in, although I don't really need to. So it's going to be 0 for x less than 0. I don't really need to put that one in, we're going to, just for the sake of being complete, x to the 4 divided by 4 for x being between 0 and then 2x, this one we need to be careful, divided by 3 minus x squared divided by 12, press the arrow key first before you do the divided by 12. Okay, since it's very easy to make a mistake, minus 1 divided by 3, and that's the values between 0, no it's not, it's between, so just go back, it's between 1, so you need to be very careful not to make a mistake, x, control, x, and 4, and then 1 for x is greater than 4. So just check that. Okay, it's good I did check it because I just realised I've made a mistake. It should be x squared over 4. So going back to this and just changing this to squared and then putting that down there and now pressing enter, we get the reasonable looking graph that we wanted. Okay, I'm only going to be interested in this bit down here. So I'm just going to move the label a little bit out of the way if I can. It's got quite big, the label. So we're going to do menu, window zoom, and I'm going to do a box zoom. Let's start again. So try again. Menu, window zoom number 4, number 2, and then I'm going to do a box zoom with this bit here, just making sure I get a bit more than 1. I go at least 4. So 1, 2, 3, 4, and that should be okay. Pressing escape, and then I get a reasonable looking graph. Looks very similar to a community frequency graph. So here's a screenshot, and they're drawing the graph. So marked on 0, 1 and 4, and here 0, a quarter and 1, and drawing my graph, I get that. And then labeling it, y is equal to x squared over 4, y is equal to 2x minus 3 minus x squared minus 1/3, and y is equal to 1 for greater than 4. So it looks very much like a community frequency graph. Right, the last part is to calculate the median. Now we could use the graph, but the median is the domain in the domain 1 to 4, and the reason I know that, as before I worked out f of 1 is equal to a quarter, and we want the value here where this is actually equal to a half. So let the median be m, f of m must be equal to 0.5, so I take the bit for between 1 and 4, so and put m in instead of x, 2m over 3 minus m squared over 12 minus 1/3 is equal to a half. This is a quadratic, so it's going to be m squared over 12 minus 2m over 2/3 of m plus 5/6 of is equal to 0. Multiplying through by 12, we get a nice easy quadratic. M squared minus 8m plus 10 is equal to 0. And I'm going to go to my GDC to work this out, or use the quadratic formula. So go into the GDC and go into calculation mode, and then go in menu, number 3, algebra, polynomial tools. We're looking for real roots. Put in the coefficients of 1, minus 8, and 10, and press OK, and press enter. Now we get 2 values, okay, but we cannot include this value because it's outside of the original domain of 0 and 4, so the median must be 1.55. So going back to my piece of work, there's a screenshot, and therefore the median is equal to 1.55. Okay, it's quite a long video, quite a few techniques there with the calculator as well, and so you need to be very, very, very careful that you don't make a mistake.